so we're going to talk about multiplying monomials. But before we do that, I want to talk about what is a monomial. So if I look at the word monomial, we see the prefix mono, which means one. Nomial means term. So a monomial means you have one term. That's what we're talking about, monomials. And we're going to be multiplying two monomials together. These monomials happen to have exponents. So we have m to the third times m to the fourth. So right now we should realize that we have the same base. Both of these monomials have the same base. The base is m. What's another way of writing m to the third? How can I expand m to the third to make it a little more, my cord is stuck, oh no, to make it a little more easy to understand? Caroline? So m to the third is equal to m times m times m. Not too complicated on this one. So then let's multiply that by m to the fourth. What's another way of writing m to the fourth? Karis?
M times m times m times m.
Yeah, after 3 it's hard to remember how many times you said it. But you did it perfectly. So that is m to the fourth. How many m's am I multiplying together? 7. So really, m to the third times m to the fourth is going to be equal to
M to the
m to the seventh. Now, is there an easier way to do this other than expanding these? And the answer is going to be yes. Grace?
You just add the exponents?
I just added the exponents. So this brings me to my rule. And for you in 7th period, it's time to write your rule on the outside of your folder in Sharpie. So the rule says a to the x power times a to the y power is going to be equal to a to the x plus y power. So just like here, we had m's, m to the third, m to the fourth, and we can expand it, but that takes a lot of time. Why don't we just add the two exponents together? 3 plus 4 is equal to 7.
It is?
Shocking. I know. All right. So let's take a look at our next problem. Now this one is a little bit more complicated because instead of only having one variable in our monomial, we have 3 variables in our monomial. So we need to go back to the idea of what is a monomial. A monomial is something that has one and exactly one term. This is a monomial because when you're multiplying all these things together, they form one piece. They are one. When you talk about polynomials, poly meaning many, nomial meaning terms, each term has to be separated by an addition or a subtraction sign. For example, if I had a plus b, this is a binomial. Bi meaning two, nomial meaning terms. So we have one term, two terms. The terms are not the same. We cannot add a's and b's, so we are stuck with having two terms. If this is a binomial, what do you think this is called? Don't answer until I finish writing. What do you think that's called?
Trinomial.
That is a trinomial because it has 3 terms. Now let's see if I can trick you on this one. How about this? How about this one?
Polynomial.
Oh, you got it.
Really?
After 3, we just refer to them as polynomials. Poly meaning many, nomial meaning term. So we're not going to call that a quadnomial. We're just going to call it a polynomial.
No, it's a triple because you can add.
Okay.
X times.
We can't add them together because x and x squared are not the same.
X squared and x cubed.
X squared and x cubed are not the same thing. They have to be exactly the same to be combined. That was a good question. Okay, so you know, because of the I always mess this one up. Commutative property of multiplication, that we can rearrange the order any way we want, and the answer will be the same. So right now I have a times b times c, and obviously we have the exponents, and then over here we have a, b, and c all being multiplied together, and we're multiplying these two monomials together. But can I switch the order around and still have the same product? Yeah. Okay, so I have an a. What power is this a taken to?
To the first.
It's to the first. So I'm going to write a little 1 here just to make it a little easier for me to understand what's going on. Do I have any other a's that I'm multiplying here?
Yes, a to the second.
Thank you for raising your hand very much, Liam. I have a to the 6th. So I have a to the first times a to the 6th. What other terms have the same base? Yes, Rashid.
B to the second and b to the fourth.
So I'm going to multiply b to the 2nd times b to the 4th. And again, because of the commutative property, thank you. Because of the commutative property of multiplication, I can reorder things and get the same answer. And that's what allows me to do this. Finally, what else will I have that should be all together forever? Aw, Eric.
C to the third and C to the second.
C to the third times C to the second. Okay, so let's multiply these together. A to the first times A to the 6th is A to the
7.
Zach is making sure that he speaks loudly enough to get his voice heard on the video. Okay, it's good to have goals. B squared times B to the 4th is equal to B to the
6.
And C to the 3rd times C to the 2nd is C to the
6.
And there we go. We are done. Yeah, it's really not bad. The thing about rules of exponents is when you have one problem that involves all of them, and that's when it gets complicated. But the rules of exponents just by themselves really aren't too bad. All right, so let's look at this last one. Actually, better yet, what I want you to do is I want you with your partner to try to solve this one on by yourself. I'm going to pause the video. I want you to solve it by yourself, and then as a class restart the video once we have answers. 5, 4, 3, 2, 1, 0. Okay, so at this point you should have had enough time to get to the bottom of this problem. So do I have a volunteer who is brave enough to come up here and explain how to do this for posterity's sake? All right. The last person up to the board today was, I believe it was Karis. So Karis, would you please someone with their hand up? Please welcome George to the stage. Thank you. You're welcome.
Okay, so there's two F's, so you'd add them together, so F 11, then times, and then there's two G's, so then G 1, so G3, because the G is a 1, and then there's the H, but it doesn't have anything, so it's just H1.
Now, in this case, one monomial has an H, the other monomial does not have an H. You're allowed to multiply or divide things together that are not the same. That is okay. And so if I have H to the first in one of my monomials and no other H, I just still have that H to the first. It doesn't change. Are there questions on this skill, multiplying monomials?
Do you have to put to the first?
You do not have to put to the first. It is, if there is no exponent, it is assumed it is to the first. For this lecture, I am writing to the first, so it's a little more clear and explicit, but you do not need to write to the first. Are there any other questions? Bueno.
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 All right, let's just go to the next. No, I want two separate videos.
He's gonna have great edit.
Yeah, I'm not going to edit this. I just slop everything up there.